Okay, here is the an explanation on the questions that you missed on Chapter 7. So here is the Chapter 7 test. Okay, here's the Chapter 7 test which you took. Okay, these are the questions that you missed. Okay, 3, 4, 5, 7, 8, 12. And then on the other one is 16 and 18. Okay, so I'm going to explain these as much as possible on this piece of paper. Okay, so here's number 3. Okay. So the question, you can see there are 3 terms. What they wanted you to do is to simplify so that you no longer have like a power of power. Okay, so whenever you see a parentheses, you're going to have to simplify that. So when you have a power of a power, then you have to multiply. So this will be 4 times the 1 here, so that will give you 4. And then 4 times 2 will give you 8. Okay, the 2 is outside the parentheses, so it doesn't change. Here again, you have this thing in the parentheses raised to the second power. So you have to raise this power to another power by multiplying. So this will give you 4. And then 4 times 2 will give you 8. So now in the next step, you can see that all 3 of these terms are like terms because they have the same variables raised to the same degree. So which means that now you can combine like terms by adding their coefficients. So 4 plus 2 plus 4 is 10. And then you just copy down the variables. And that's it. So it's a to the 4th, b to the 8th. Okay, a to the 4th, b to the 8th. Okay, that's for all of them, right? So you just have 10 of those. So that's your answer. The next one, number 4. Okay, this question, okay, you can see that there are number terms. There are numbers here that you can simplify. There are a terms that you can simplify, and then there are d terms. Okay, or not terms, I'm sorry. They're like these variables that you can simplify. So I'm going to do them separately in different parts. Okay, so 4 over 8 is the same as 1 over 2. So that's how you simplify that part. And then a to the negative third over a to the second is this. You have to use the addition and subtraction rules. So you take the exponent, the negative 3, and then you subtract the 2 because this part, this a, is on the bottom, is in the denominator. So that's what you do. Okay, so you take negative 3 minus the 2, and that will give you a to the negative 5, right? Because negative 3 minus 2 is the same as negative 3 plus a negative 2. And that will give you 1 over a to the 5th, okay? Because that's what this negative does. That means it's actually in the denominator. Okay, now we're going to look at the d part. So now you have this d to the second power. You're going to subtract the negative 5. Okay, so let's look at that. You're going to subtract the negative 5, which is the same as adding a positive. So it becomes 2 plus 5. So it's d raised to the second power. Now when you put all of these 3 components together, you end up with, okay, you draw a line. And then this 1/2 has a 2 on the bottom, so you write the 2 on your bottom. The 1 goes on top, but you don't have to write it. And then over here you have, 1 over a to the 5th. So the a to the 5th goes on the bottom. And then finally the d to the 7th, there's nothing, to it. So this is just goes in numerator like that. Okay. Number 5. Okay. Number 5, again, you have something in parentheses raised to the power. So that means everything inside the parentheses has to be raised to the 3rd power. And also here, everything inside this parentheses has to be raised to the 2nd power. So that's what I'm doing here. I'm raising 3 to the 3rd power, r cubed raised to the 3rd power. Okay, that comes from here. The cube raised to the 3rd power. And then t to the 5th raised to the 3rd power. On the bottom, you have negative 3 being raised to the 2nd power, r squared being raised to the 2nd power, and t to the 7th raised to the 2nd power. So you do all of them separately. 3 to the third is 27. These two have to be multiplied together because it's a power of a power. So you get 9, and then you multiply these, you get 15. On the bottom, negative 3 raised to the second power is positive 9. And then r and squared to the second power is r to the fourth power. T to the seventh raised to the second power is t to the 14th power. Now you simplify. So 27 over 9 becomes 3. This will give you like the r to the 9 minus 4, which is r to the 5th. And then this you would take 15 minus 14, you get 1. Okay, and then everything is over 1. So this is, you know, when you simplify this, there's a 1 on the bottom. But you don't need to write 1 because, you know, you don't need to. So your answer ends up being 3r to the 5th t. Okay, number 6 is the next question. Oh, I'm sorry. Okay, so the next question we need to do is number 7. Okay, this one is kind of hard. So the question starts out with just this, okay? And you see that on the bottom of this fraction, you have a radical. So what we need to do is rationalize the denominator, okay? We need to rationalize the denominator by multiplying this term. So this is the question, okay? This is what you start with, okay? And then you're going to see what's on the bottom. It's radical 10 minus 3. You're going to multiply it by its conjugate, which is negative 10 plus 3. So you keep the terms just the way they are, except you change it to now plus because there's a minus. Okay, and pretty soon we'll see why that is. So when you multiply that on the bottom, you got to do it on the top as well because you don't really change this thing. You're just rationalizing it. Okay, so you got to multiply the same top and bottom because this becomes 1. So it's like multiplying this by 1, which doesn't change the value. It just changes its form. So now we're going to multiply this, distribute on top. So I have 5 radical 2 times radical 10. So you multiply what's inside the radical, okay, to, you know, the radical with the radical. So the 5 stays the same. 2 times 10 gives you 20. So now you have 5 radical 20. And then you're going to distribute this to the 3 as well. Now the 3 is not inside the radical, so you multiply it by the 5. Not by the 2, but by the 5. Because they're both numbers, okay? They're not radicals. So 5 times 3 gives you the 15, and you still have radical 2. So you keep it. Now on the bottom, you're going to multiply the first with the first, right? Like FOIL. So radical 10 times radical 10 gives you radical 100. And then FOIL. So the O gives you outside. So you take radical 10 times positive 3, and that gives you this one, 3 radical 10. And then on the inside, you have negative 3 times radical 10, so you have negative 3 radical 10. And then negative 3 times positive 3 gives you negative 9. Now you can see that these two terms can cancel out, okay? This is a negative, this is a positive, they're equivalents, they cancel each other out. Now we're going to come to here and see if there's something we can take out of the radical. So in the 20, we have 4 times 5, and 4 can be, you can take the square root of that, and that will give you 2. So you end up with 5 times 2 on the outside, and then what remains inside the radical is 5. Okay, this 5 remains inside because you can't take the square root of that. And then this part you just keep here. And then here you have radical 100. Radical, or the square root of 100 is 10. So you end up with 10 minus 9. 10 minus 9 on the bottom. And that will give you a 1. And then on the top, 5 times 2 is 10, so you have 10 radical 5 plus 15 radical 2, and the 1 on the bottom doesn't need to be written, so your answer is just this top part. Okay, you can see that. right here. Number 7, the answer. Okay. That's how you got it. Okay. Number 8, they want you to compare, okay? Number 8 says, describe how the graph of g of x is equal to 5 times 2 raised to the x power is related to the graph of f of x is equal to 2 raised to the x power. So you can see that they want you to basically compare this to this. Now you notice that both of them have the 2 raised to the x power, 2 raised to the x power, except this one, everything that's true here, you're going to multiply it by 5. So that makes whatever your x is, whatever number you get, okay, you're going to multiply by 5 to get this one. So everything is stretched. The y is going to be 5 times higher, okay, every single, for every x. So that's why your answer is the g of x is stretched vertically. So that whereas, you know, your original graph may have looked like this, your new graph is going to look like a lot higher. Okay, it's stretched up vertically because everything has to be 5 times more. Okay. Here's the question. Okay, so number 12, here's the question. Okay. Now when you see the question like this, you want to make sure that they have the same base. So since the base here is 2, you have to change this to 2 as well. And you know that 64 is a multiple of 2. Okay, so let's see, how can we change the base to 2? Okay, for the 64. Well, 64 is equal to 2 raised to the 6th power. So you can now substitute this for this. Okay, and that's what I'm going to do here. Instead of writing 64, I'm going to write 2 raised to the 6th power in this question. You see that? And then this is being raised to this power, so I'm going to write that again. Okay, all I did was substitute this for that. And that's equal to 2. Now this is 2 raised to the 1st power. Okay, now I'm going to simplify this part, okay, by distributing, you know, multiplying 6 by this. So that will give me 12x plus 18. Now 2 raised to this power is equal to 2 raised to this power. That means this power is equal to this power, which means 12x plus 18 is equal to 1. Okay, this part is equal to this part, right? Once you do that, you subtract 18 from both sides, you get negative 17 on this side, and then you divide both sides by 12. X is equal to negative 17 over 12. And that's the answer. Okay. Okay, finally, 16 and 18. Okay, 16, it says write each expression in radical form. Here is your question. It's not in radical form yet. Okay, so you just have to change it to the radical form, that's all. The 10 is not being raised to the 1/3, so the 10 remains outside of the radical. And the x is the only thing that's being raised to the 3rd power, so you just write x on the inside of the radical, and then you write a small 3 here to show that it's a cubic root, not a square root. Okay, so I hope that's, you know, explanation enough. So like if I had something like 4x to the 1 to the 4th power, then I would write the 4 and then the radical, the x, okay, is to the 4th root. All right, number 18. Okay, graph this equation, y to the 1/6 to the x power, and find the y-intercept and state the domain and range. Now when you graph it, it's going to look something like this. And then the first thing they ask you is the y-intercept. So where's the y-intercept? The y-intercept is right here. So that's 1. That's what this 1 means. Domain means like where can the x be? Like where does this line extend to? Well, it can keep going in this direction forever, and it can keep going in this direction forever as well. So it goes on infinitely in both directions. That means it's all real numbers. That's what D is. The domain is the how far can the X go. Now for the range, you can see that this thing kind of approaches 0, right? This thing is never going to drop below the X axis. So that's why the range is such that Y is always going to be above 0 or more than 0. Okay, and that's what this range means. Okay, so I hope these are good enough explanations. When you do your test is going to look like this. You do have one question here where you have to graph just like that question. Okay, so you just need a few, probably, 5 or 6 points, and then you can graph, a line, or you can use a graphing calculator online and then graph it online, and then you just have to answer these questions. Okay, what's the y-intercept of this graph? What's the domain and range? Okay, just like here. Okay, you have to tell like whether or not the domain and the range is all real numbers, or are there some limits like the range here. Okay, all right, I hope this helps. I'm sending you this test also. Your test has been redone. I am giving you a new test. Okay, I removed all the questions that you don't need to do. These are the ones that correspond to the ones you missed. And then you just have to do these and turn this one in, and I will update your test grade according to this.